Hello, everyone. Welcome to the Delegator webinar.
Hi, everyone. Just a quick information is that we are recording this and we will put it on YouTube so you can watch it, or you can watch it through GoToWebinar as well. So, handing over to you, Jack, to take us away.
Nice. Well, do we have everyone here?
Yeah, let's make sure that we have everyone there.
Yeah, let's wait just a couple of minutes for folks here, and then we can go ahead and get started. Let me also share a couple of links for this. There's the Delegator guide, which we will be discussing in detail. And then I have a couple of other links here. The chain that I'm going to be interacting with is Gaia 11,000, which is a test net, and I have a node that's a validator running on that network, as well as a command line hooked up there. So I'll be speaking about that in much more detail. There's one explorer for the blockchain, and another one is Big Dipper. So I'll also speak briefly about explorers. Let's just give folks another couple of minutes here. Is anyone able to see those links that I just shared?
I don't see them personally.
Yeah, I see them. Just in case everyone doesn't know the platform, in your sidebar, you're going to have a list of options, so you can ask questions. So throughout the session, Jack and Gautier will be taking and answering your questions to make it kind of interactive. And then there's the last tab on your sidebar that has the chat, and that's where Jack is putting in the links that you need to be referencing for this.
All right, a couple more folks joined. Just wait one more minute here.
Happy Valentine's Day.
Oh, yes. Valentine's Day.
We're spending it with all of you.
I know, it's the nicest way to spend Valentine's Day on the blockchain.
Yeah.
Bonus points for good Ethereum Valentine's Day memes. Okay. All right, 5 minutes into time, I'm going to go ahead and get started here. So just to give you guys a little bit of background here, my name is Jack Zamplin. I'm the product manager on the Cosmos SDK, and I'm here to talk about delegating in the Cosmos mainnet, which we're going to be launching here within the next couple of weeks. The bulk of this discussion and walkthrough is going to talk about the Gaia CLI, which is currently the most secure and suggested way to interact with the blockchain. So I'm going to be going over a number of commands and different ways to use that CLI. I will also be taking questions about delegation throughout this webinar, and I'll pause at appropriate times to answer those. So I'm going to go ahead and get started. So the Delegator guide has everything that you're going to need to walk through and do this delegation. Now, if you're not familiar with command line interfaces and command line tooling, there's a little bit of learning that you're probably going to have to do to figure that out. We offer support in the forum as well as in the Riot chat. So if you guys run into issues during installation or getting up and running, please ping us. We will make sure to get you guys up and running. Also, as you can see by this warning, you're dealing with pieces of information that control access to your private keys. So obviously, as you know, in crypto, if somebody steals your private keys, they've got your money. So be very, very careful when inputting private keys into any piece of software. There's going to be a number of warnings throughout this guide saying roughly the same thing, and I'm just going to say it once at the beginning and probably again throughout, but be sure you know where your seed is going and not to share it too broadly. And another piece of this is that we have added support for, sorry about that, ledgers and other hardware wallets to the Cosmos SDK. I'll be showing you how to use the ledger to help secure your key as well throughout the process of this, this walkthrough. And again, if you have any questions during the presentation, please don't hesitate to ask them. Drop them in the Q&A bar. Gautier will answer them, or I will answer them in real time. Thank you very much. Any questions or concerns before we start?
Wondering, Jack, would you prefer if we just unmute the whole attendee group and they can like verbally ask questions?
Yes. Oh, well, yeah, let's give that a try. And if they get too disruptive, then we can mute them again.
Okay, let me figure that out then.
Or you guys can just drop comments and questions in the chat. Okay, I'm gonna go ahead and get started. Can you guys hear me? I got muted there for a second.
Good.
Okay, yeah, I was muted too.
All right. Okay, so obviously the first step here is that you need to install Gaia CLI. Now, as I mentioned, this is a command line tool. If you're not familiar with the command line, this is likely going to be a slightly new process to you. However, I think most folks in crypto at least have a little bit of experience with it, whether it's like compiling Bitcoin, which I remember the first time I did that was eye-opening and fascinating. All the streaming output going down, having no idea what any of it means, and basically ending up learning that C++ is terrible. Hopefully you learn through this process that Go is less terrible. But I think probably the hardest part of this installation is going to be installing and setting up a Go environment. If you're on Mac, I would suggest that you use Brew to do that. It's quite easy. Linux also has excellent package installers. I'm less sure of the state of the Windows ecosystem, but if you guys, again, if you guys have questions, drop in the forum, drop in the Riot chat, we'll help out. And just to kind of walk you through what that installation process looks like, you're going to, if you want to install from the source, you would pull down the Cosmos SDK. You would check out the branch that you wanted to check out. So right now, the launch branch is 0.3.1.2. If there's another breaking change, we might increment this version before launch, but it's going to be something very close to this. You would check out the version of code that you want to run, so to make sure that you're in sync with the rest of the network. And the first command that you're going to run is make tools. This downloads any tooling that is necessary for building the binary itself. I already have the tools on my system, so we don't really need to do anything there. But if it's your first time running this command, it's going to download a bunch of stuff from the internet, and it's going to take like a minute or two. The next one that you're going to want to run is make vendor deps. So the Cosmos SDK relies on a number of other Go projects, excellent projects throughout the ecosystem, like BTCD by the Lightning Network folks, a bunch of cryptography work by the Go core team and other very highly respected cryptographers. And this command downloads all of the necessary code to build the Cosmos SDK. So again, I also have all of these repositories pulled down locally. This one might take a couple more minutes depending on the speed of your internet connection, potentially up to 5 to 6 minutes. So just be patient while that make vendor deps is running. And then finally, the last thing you're going to run is make install. And this is going to actually build the binaries that you use. The way that you can see if you've done it correctly is by running the binaries. So one of them is Gaia CLI. We're going to be working with this extensively throughout. And the first command that we're going to talk about is version. So this gives you version information, what get commit it was built from, what the actual version is, where I built it, what the Go version is, and sometimes it also includes the vendor hash. Gaia D, which runs the network, or if you're running a validator, I know there are a couple of validators on this call, so you're very familiar with Gaia D, also has the same stuff there. So this is how you know if you've compiled and built correctly. You want to make sure that this version here matches whatever version that you think you have built. And if you do it that way, you're pretty much guaranteed to get the proper result. The next thing that I want to talk about is Cosmos accounts. So before I dig into this page right here, let me just sort of give you guys an overview. When you participated in the fundraiser, or as you'll see later, are generating a new key, you're given a mnemonic, which is 12 or 24 words that imply some sort of that are randomly generated and can be used to derive the randomness that is at the core of all of your private keys. Now, that phrase, if anyone has that phrase, they can steal all of the money out of all of the accounts that are derived from that. So that phrase is the single most important piece of information to keep secret. Keep it in your ledger, keep it in a bank vault, keep it in a paper wallet. The Bitcoin community and Ethereum communities have a lot of excellent guides out there on how to keep your seeds safe. If you need, and we link to a couple of them in this document, as well as tell you a number of the best practices on that. So especially if you're storing any significant amount of money in these seeds, please make sure that you're securing them properly. So the next thing to think about with these seeds, that seed is can be the basis for potentially infinite numbers of different private keys. Because it's a randomness seed, you can generate other randomness off of the top of it in a deterministic fashion, and that allows you to have multiple accounts and interact that don't have any obvious connection to each other. So if you've ever heard of HD wallets, that stands for hierarchical deterministic, and that allows for this account generation throughout with just one seed. So that's exactly the way Cosmos wallets work. And you can see in this diagram here, we have the mnemonic, and with that mnemonic, we can generate a number of private keys that have associated public keys and addresses. And we'll see this more explicitly as we go throughout the tutorial here. So important to keep in mind that funds stored in any account are controlled by the private key. Again, keep those private keys and mnemonics safe, or else people will steal your money. Another warning. One thing to note, Cosmos accounts and public keys have prefixes to them that sort of indicate which type of public identifier this is. Cosmos accounts are prefixed with Cosmos. Cosmos public keys are keys list are prefixed with Cosmos pub, as you may be able to see here if I increase the size on this. And there's a couple of other prefix types that we'll see, especially for validators, throughout this webinar. So I'm going to continue from there. So this here is a piece that I'm not going to show, but I will speak to. We were talking about these 12-word mnemonics. One way you can do it is to generate and store your 12-word mnemonic on a hardware wallet and with a backup on paper. This is generally considered best practice in the crypto industry, and it's what I'm going to be doing with my atoms on Mainnet. So here's an example ledger, and we're going to show you how to use that in conjunction with Gaia CLI, but the instructions there walk you through generating a new seed with the ledger. Another way that you can generate a new seed is using Gaia CLI. So you see I have a couple of keys here, but if I type Gaia CLI, keys, oops, sorry. Let me increase the size here a bit. Keys add, and we'll call this Jack key. The first thing that we need to do is enter a password. This password is going to be used to obfuscate the mnemonic on disk, so that the only way to get it off the disk is with the password. And once you do that, and you've generated the key, it's going to give you this mnemonic here. Now, obviously, I'm showing you this mnemonic, but this is a testnet address. The way that the randomness works, there's an extremely, and we're talking astronomically low chance of collision on these things. So no one used this mnemonic for anything because it's out there in the world and people could easily steal it. But this is what you're going to want to save. And when you initialize your ledger, you're going to get something that looks like this as well. So if you're generating your keys on a computer, make sure you save this offline somewhere so that you can then, let's say that I deleted this and I wanted to restore this key elsewhere, you would use the recover and then pass the mnemonic in as the argument to recover that key. As you'll notice, as I mentioned earlier, and you saw up in that diagram, there is the address. This is used for sending and receiving, as well as the public key, and that's used for verification of messages. I'm just going to pause here and see if we have any questions or anything in the chat.
Yeah, we did have one question.
Yeah, absolutely. Which one was that?
If I think my ICO seed has been compromised, is there any way to get a new seed before mainnet launch? The answer is no. If your seed has been compromised, we strongly advise that you send a transaction as soon as transfers are enabled, but we have no way to generate you a new seed because there is no way we can prove that it was you and not the hacker that requested the change.
Yep.
So.
Also, there's no way on our side for us to recover those private keys. When you generate them, they are yours and yours alone. They are a unique piece of digital information that is unforgeable. It's what makes these systems secure, and it's one of the reasons that makes them extremely hard to use. So Gautier, great advice on sending a transaction immediately to get those funds out of a potentially compromised private key.
Sure, and maybe to insist on something, again, you have two private information. The first one is the mnemonic, and the second one is the private key. The private key is generated from the mnemonic, right? But the mnemonic cannot be found from the private key. And then you have the address that is public information. So please never share your private key, never share your mnemonic. If you lose your private key, you can always restore it with your mnemonic. But if you lose your mnemonic, you lose access to all your accounts. So long story short, do not lose your mnemonic, do not give it to anyone, and secure it properly. We have no way as a company or anyone has, no one can find your mnemonic for you if you lose it, unfortunately. So you are responsible for securing it.
Yep. Thank you for that note, Gautier. All right. So the next step in this is figuring out, so let's say that you're following best practices, you've gotten a ledger, you've initialized it. Now, what do? So in this guide here, we tell you how to go use the Ledger application, the Ledger Updater, to install the Cosmos application. There is a specific Cosmos application that allows you to interact here. And what you would need to do there is run Gaia CLI keys add. I've already got a Ledger key on here, so I'm going to call this Ledger 2. I'm going to say Ledger, and then I'm also going to say account 2. The account 2 is because I've already added a key from this ledger. You can add as many of them from the same randomness seed as you want. You just need to specify a separate account. So I'm going to go ahead and add this. Oop, I haven't opened the Ledger app on my Ledger itself, so let me unlock this thing here. Give me just 2 seconds.
Yeah, and the account is actually the path that is used to generate the account, which is like the pair of public key and private key. So if you type account 2, you will obtain private key 2 from your mnemonic and address 2. And if you type account 2, you will always find the same public key and private key pair. That's why it's called deterministic.
Great note there. And you can see here, when I add the key just on the computer, it's giving me the mnemonic. But because the mnemonic is stored on the ledger and only on the ledger, and in fact, this computer can't access that private key from the ledger, we're just giving you the addresses that are generated from that private key. And that's because of the integration that we wrote with the ledger.
Yep.
So I just showed generating a 12-word phrase with the CLI on the computer. One note, if you run these things on the computer and you're very paranoid about that 12-word phrase getting leaked anywhere, there can be, especially if you use the recover function with a raw mnemonic, that mnemonic might be stored in your computer's history in a few places. There's a note here on how to remove that history. This is common on all POSIX systems. I'm sure Windows works roughly similarly, but you're going to have to probably run some different commands to delete that history. This is what I did with the ledger and the account. In the same way that you can recover multiple accounts from a single mnemonic using a ledger, you can also do so with just the CLI. So as far as accessing the network, if you are a validator, you are already on the network and you're likely to access it through your nodes. If you're delegating, you're likely to either run your own node that connects to the network, and then you can validate the blocks and validator set and create transactions through that node. Or there's also the option to, if you trust one of the validators, you can use one of their nodes to submit transactions. So, and as far as connecting to a remote node, I can show you an example of how to do that right here. So Gaia CLI has a configuration file, and if you type Gaia CLI config, it'll show you everything that's in your configuration file. So there's a number of flags that you would have to type in for almost every command. Chain ID is one of them. Obviously, because Cosmos is a network of many different chains, you have to specify which chain you're talking to as part of connecting and querying that chain. So storing it in the configuration prevents retyping. Another one is, which node are we reaching out to for this data? This is a cloud node that I'm running right now that's connected to Gaia 11,000. So all of the queries from Gaia CLI are going to that cloud node. Other options are things like, and if you would like to set a configuration option, you would say key. So what I'm going to set here is the output type. And I want that output to be text. So we're going to save that key to Gaia CLI config, and then if you read it back out again, you'll see output text. The other option there would be JSON. All of the commands in Gaia CLI will output either a text format. If you're working on your computer just with the CLI, the text format is what you're going to want to look at. If you're looking to do programmatic interactions with the CLI, the JSON is great. And just to give you and I can show you later what that looks like. So before you start doing any of these other operations, it's generally good to set up your CLI configuration so that you don't have to do a ton of typing.
Yeah, maybe one note there, just so for people that maybe it's not totally clear, but the CLI is the tool that you use to interact with the node, right? And the node actually contains the information about the blockchain, right? So as Jack said, you have actually two options right now. You can either run your own full node, but be careful because it really comes with high resources requirements. But this is actually the most secure option. And if you do not want to run your own node, you need to trust someone else's full node. In that case, that's what Jack just showed. You need to specify a remote full node that your Gaia CLI will interact with. And in this case, you need to be sure that this node is someone that you trust. One note is that they will never be able to steal your private key or send a transaction in your place. All they can do is maybe lie on the result of your query. So for example, if you query what is my current balances, they can potentially lie and tell you a false balances, but in no case are they able to actually send transaction in your place or steal your funds.
Awesome. Thank you for the update there, Gautier. So just as that's a good note on setting your configuration before you start doing it. So I'm going to talk through all these different queries. As a delegator, these are probably the queries that you're going to be most interested in here. They have to, sorry for the hiccups. They have to do with account balances, staking and delegation, like i.e. which validators am I going to use, how am I going to delegate, what do my delegations look like, as well as distribution. How much inflation have I accrued in the time that I've been delegated? And then also governance proposals as well. So part of your duty as a delegator as well as a validator is to vote on upgrade proposals for the network. We have an in-protocol way of doing this, and there's a number of different things about that governance platform. One thing to note is that things like Hubble actually give you the ability to vote on proposals, deposit, vote through the UI, and they help you with the creation of these transactions. So it's definitely a nice addition, but I'll go through all these. So let's look at a couple of accounts. Let's look at a couple of accounts here. So what I'm doing here is I'm pulling the address for my delegator key, and I'm using that to query the account. And just to show you the output here, that's what that looks like. So you can also run that like this. And it will give you the same thing. So this account has a bunch of muons, which is the staking token for Gaia 11,000. Here's the address. Here's the account number. This account number has to do with the number of accounts on the entire chain itself. So any accounts that have coins in them or have been sent coins have account numbers created. The other key that I have here is a key stored in my ledger, which I'll then talk about how to interact with as well. You can see the pub key there, as well as its balance, slightly fewer muons, and account number. I created these at roughly the same time, so they have similar account numbers. Next is validators. So as a delegator, you're going to be interested in which validators to stake with. And while these great services like Hubble or Big Dipper or other explorers will show you these list of validators and all of that same information, you can easily get it through the CLI. And in fact, the CLI returns are what is used to construct these UIs. So here, maybe I'm going to zoom out a little bit so this is a little bit more readable. Obviously, there's a lot of information on screen. I'm not going to dig into all of this, but let's pull out one of these validators and get some details there. Or actually, these guys. Query, sorry. All right, there it is. So this validator, they've got an operator address. As I mentioned earlier, there's going to be some other different key prefixes. These are specific to validators, and it's similar to that account and pub key that we were talking about earlier. This is the pertinent validator address you'll see in the CLI documentation as well as in the delegator documentation. We talk about validator addresses a lot. Those are going to be Cosmos val oppers. And you can query the validators directly using that as well. This is going to tell you whether or not they're jailed, i.e. they've done something bad and they've been punished for it. Whether or not they're bonded or unbonded. It looks like this validator has all of their stake bonded, how much staking token they have bonded. And then one nice thing about these is we give the validators some space to put in a description, and many of them, especially the reputable operators, will put in their websites, so you can go learn a little bit more about that particular validator. So these folks, validator.network, I think they're based in Europe somewhere. So maybe the site's taking a minute. Yes, it is. And they list here exactly what they're offering in terms of validation, infrastructure, different peering, who the team is. So as you're in the process of deciding who to delegate to, useful, and if you're interested, looking through this list of validators and kind of seeing what they're all offering. It's a good way to pick that out. Another good way to do that is to look at this commission line. So as a delegator, when you delegate to a validator, that validator is offering a service. And they, in fact, run a lot of hardware that helps you, as delegators, avoid having to do that. So they can charge a fee. The amount of those fees is determined here. So make sure that you look at that. It looks like they're charging 0.1% on delegations with a maximum of 1%. And they'll only be able to change that at 0.1% a day. So that's
more precisely, like the rate is the commission that is applied on your rewards in terms of percent. So here is 10%. So let's say you delegate to a validator 1,000 atoms, and the rewards are maybe 100 atoms. Then 10 atoms would go to the validator because the rate is 10%. The maximum rate is the maximum commission rate that they can ever charge. So here it's 100%. So it's not really useful, but let's say if it were 50%, 0.5, it would mean that this validator would never be able to charge a commission higher than 50%. And then the maximum change rate is there to ensure you that they will not change their rate, their commission rate more than this rate of 10%. So I think it's each week. So this means that each week they cannot increase their rate more than 10% of what it already is. And what it gives you as a delegator is the insurance that they will not go from 10% commission to 50% in one day, right? You can see that they will not be able to increase their rate too much in one go, right? And therefore, if a validator starts increasing their rate too much, you are free to unbound or switch to another validator.
Much better information than I gave there on those commission rates. I was obviously wrong. So thank you very much for correcting me there, Gautier. Also, in the documentation, we have links to the specifics for all of this stuff. And if you have any problems, please ask us here, or again, reach out to us over any of the support channels that we have as well. Continuing on here,
maybe one more info, Jack. You didn't mention minimum self-delegation.
Oh, I didn't. Yeah, absolutely. Do you want to?
Yeah, I think it's so. This is I think this is just in the same vein as before. The minimum self-delegation is set at the beginning when the validator is created, and it's also an insurance policy for the delegator. So here, the validator network, it was I believe 3,000 atoms. So what this means is that this validator will never go beyond 1,000 atoms of self-delegated stake. And what self-delegated stake is that when you delegate to a validator, right, it is you as a third party that delegates to a validator operator. But the validator operator themselves can delegate to themselves some stake. And what this gives you as a delegator is the insurance that they have skin in the game. And to understand that, you need to understand the risk you bear as a delegator. As a delegator, when the validator you delegate to misbehaves, that is, for example, they sign 2 blocks at the same height, then they will get partially slashed. And not only they will get slashed, but you as a delegator, if you trusted them, will also get slashed. And so the minimum self-delegation is there to ensure you that they have a minimum amount of skin in the game. Because if this self-delegation is at 0, this means that the only stake that is at risk is yours, the delegators, right? The validator doesn't really have skin in the game, which can be fine. But for delegators that want their validator to have skin in the game, this minimum self-delegation parameter is there to ensure that their delegation will never go beyond this limit. Actually, if the delegator goes beyond this limit of self-delegation, everybody will unbound. So you're never at risk that the delegator you delegate to will have less delegation than what they state in this min delegation parameter.
Nice. Thank you for the clarity there, Gautier. So just a note here, running through the next couple of these queries staking delegations. So that address that we had earlier, the same Gaia CLI keys show, you can see if there are any delegations associated with that address. Now, this is the validator that I'm running, and there's a delegation to that validator on the machine. So here's that delegation. If you want to query the individual delegation, take the S off and then add the validator address. So again, validator address is the Cosmos val opera there, and it'll give you back that delegation as well. If you want to see how many rewards there are, you would query it for your delegator address, same one up here, and you can see the rewards I have here. One thing to mention, I mentioned earlier that you can get any of this in JSON, and you can even get it in pretty printed JSON. So a lot of flexibility there in terms of the command line tool. Another, as I mentioned earlier, there's also the governance proposals. And you can see that on the network now there's one proposal. It's called the delegator proposal. And this person thinks that delegators should all vote in governance. And you know what? I totally agree with this guy. He's really on top of it. You'll notice here that this proposal is in the voting period, so we can vote for it. And what's happened here is some funds have been deposited to this proposal to allow it to go through. So otherwise we'd have folks just spamming governance proposals. No one would really know what's going on. So you actually have to spend some currency to create a governance proposal. And that deposit parameter you can query with, hopefully you can see this, Gaia CLI. If you can't see it or you have any questions, you want me to slow down, please ask questions in the questions. You can see in the governance params what the minimum deposit is for a proposal. So the minimum deposit is looks like 100,000 muons, and here this has had 100,000 muons deposited, so it's now in the voting period. And if we want to query the individual proposal, we would pass the proposal ID, and it gives us details about that. Yep.
Maybe one note there. So you don't have so I think maybe we should do a segment on governance that explains how it works. But basically, anyone can submit a proposal on the network. But you, as the proposer, you do not have to submit the entire deposit yourself, right? So you can actually submit a proposal with a base amount of deposits, and then other people can come in and deposit on this proposal that is not yet in voting period. And then when the aggregated deposit reaches min deposit, then the proposal enters voting period. So yeah, just know that anyone can submit a proposal, and you do not have to submit the entire deposit yourself.
Yeah, and if you want to
question, does the deposit change according to the type of proposal, or is it always a standard deposit amount?
So that is set as a part of the Genesis parameters. So okay. At network launch, that will be set.
Okay.
And it's the same across all proposals, because all proposals are currently text proposals. We don't have other kinds of proposals right now. Other types of proposals like parameter change proposals, i.e. if you wanted to change how much deposit is required to create a proposal, you could submit a parameter change proposal and change that parameter. Or software upgrade proposals where someone would say, I'd like to upgrade to this specific new version of the Cosmos SDK. Those two proposal types are in development and will be added after mainnet is launched.
Okay, it looks like there's just one other question that's related to this. Are there penalties for delegators or validators who would not vote in a proposal?
So if we take a peek up here at the governance parameters, you will see that there is a governance penalty on this particular network. I think the current plan is that when we launch mainnet Cosmos, we're going to set that governance penalty to 0 so that there will not be a penalty for not voting on proposals.
Yep.
That's a double negative. Yeah, that's right. There will be no penalty for not voting.
For not voting.
Yeah, that's the current plan. We have not released the final Genesis file yet, and that may change, but that's my understanding. Okay, so we've talked about the query side of things. Just a quick note on gas. Gautier, do you want to speak to the gas prices here for just a second?
Sure. So gas is something that was introduced back in Ethereum. We also have this mechanism. So the way you can think of gas is just that we have different type of transactions, right? So you can submit a proposal, you can send a transaction, send some funds, sorry, you can bond your tokens. Different transactions have different requirements in terms of computing that is done to process a transaction or disk space that is used. So we need to put a price on each transaction, and this price is basically in gas, right? So for example, one transaction may cost 20,000 gas, another one may cost 40,000 gas. It really depends on the message that you send. And the gas for a transaction is actually can only be computed when the transaction is processed, right? So when you create your transaction, you cannot be sure of how much gas is going to cost. So what you do and you will see it a bit after, you can actually set with a flag that is called gas, the gas amount that you want to send. And if the gas is insufficient, then your transaction will be rejected. There is a way in the CLI to estimate the amount of gas that will be used. So when you use the gas flag, you can put in the value auto, which will compute and estimate the amount of gas that is required for this transaction. Of course, this is not an exact science. So we also have another flag that is called adjustment. And this adjustment flag is actually a multiplier of the previous flag. And so for example, if you want to be sure, absolutely sure that your transaction will get in, you will estimate a transaction gas cost with the gas flag, and then put an adjustment factor of maybe 2 or 3 to make sure that it will go in. So that's for the gas. Then you have the gas price, right? Because the gas is just something that lives in the software, but the only tokens of value that is accepted by the validators to process the transaction are atoms. Maybe we'll have other in the future, but at launch we only have atoms. So you need to price each unit of gas. So let's say a transaction costs 20,000 gas. You have another flag that is called gas price, which is actually the price that you set for each amount of gas. So if you put it one atom, a transaction that costs 20,000 gas will cost 20,000 atoms. And the fee that you put in transaction is actually just the gas price multiplied by the gas. One last thing to note is that the gas price is also used as a spam metric, spam prevention metric by the validators. So each validator is able to set a minimum gas price locally, and they will only accept transactions that have a gas price superior to their main gas price. So if a validator in the network has 0 as main gas price, then you can basically get your transaction in for free. But this will probably not happen. I think we're probably going to have some tools that tell you what is the average minimum gas price of validators so that you can put a gas price above that. So this is a bit complicated to understand at first, I understand that. But please go on the website and you have a written explanation that is both more clear and hopefully will give you more time to understand that.
Yeah, and just as a note on that, there really is only one thing you need to worry about, and that's the gas prices flag. And as Gautier mentioned, validators will set that, and you need to just kind of figure out what the validators have set and put something that works with them. The network that I'm currently on, none of the validators are running with fees enabled, so I can easily get transactions in. I will not be running on gas. I will not be adding gas to these transactions in the demo. So the first transaction that we're going to talk about is the delegate transaction. So I have my validator in the cloud here that I've been talking to, and I pulled its validator address. So you can get this either from any of the explorers, the Gaia CLI query show query staking validators command, or maybe your friend's validator and you just ask him for his validator address. So a number of ways to get that. In the format of the transaction is Gaia CLI TX. So there's queries and there's transactions. Staking, we're going to delegate. Here's the validator address. Here's how much I want to delegate. And here's the key locally that I'm going to use to do that. So I'm going to show you once with the delegator key and then once with the key that I have in the ledger. So now you need to sign this. And we're now waiting for it to be included in a block. Oh, timed out.
Yeah, you should put async flag. But if you put async, you will not have any feedback on it.
Okay. So I think I can run another one of these.
No, it's going to be included soon, I think.
It will be included. And we can see if it's included by just querying the account. And you can see that the muons have been deducted because they're now staked. And now if I run Gaia CLI query, staking delegations from this guy, I will see that delegation I just created. And now if we want to stake some more tokens, let's say I want to stake, I've still got 150 something muons left. We're going to stake some more here.
Yep. And just a note, you can actually delegate to multiple validators, right? You don't have to commit to a single validator, and it's actually recommended to spread your stake across multiple validators, because as I mentioned, if your validator misbehaves or commits a fault, you will also get slashed. So by spreading your stake across multiple validators, you actually mitigate the risk of getting slashed.
Yeah, great. And then here, this shows an example of the transaction completing synchronously. So you can see the height at which the transaction was included, the hash of the transaction, gas information, as well as any tags that are attached to the transaction. And you can use those to query for groups of transactions. And then if we query the delegations from that delegator, we'll see that the number of shares has increased. Let's do the same thing, but from the ledger.
And just shares just means bonded stake, right?
Yeah.
So when you have atoms, say, and you delegate it, you will obtain shares in exchange. And then when you unbond, you actually exchange your shares for liquid atoms.
So this time, I'm going to grab that validator address off of the Figment Networks. I'm going to delegate to the Figment Networks folks because they built this nice Explorer. I think they do a bang up job on their infrastructure, and I think that they're worthy of my money. So I'm going to delegate to Figment here a little bit as well. So I'm spreading my delegations out. So I grabbed that Cosmos val opper, and I'm just going to input it in this command. This is also going to be from that ledger. So this is going to be an example of signing with a hardware wallet. So it's going to block here, and it wants me to look at the transaction. I wish I could show this to you. There's
you can show it. You can show it.
Can you guys see this? Yeah, so it's going to tell you the chain ID and a bunch of other identifying information, and you want to just look through and make sure it's all correct. And it will, in fact, even show you the amount and the amount of gas in the transaction. And you would sign the transaction. I think that's right. Okay, so we're waiting for that to be included in a block.
Yeah.
But
so this error does not mean that the transaction was not included. It just means that the CLI did not get a response in time because we don't really control the block time. So maybe sometime a block will take 7 to 8 seconds to be minted. And in this case, maybe the CLI will time out, but it does not mean that your transaction did not get in.
I need to take a note to open an issue to fix that error message.
Yeah.
Okay, so now we can see that it's been included in a block. We have delegations with the ledger. And now maybe I also want to delegate to my validator here, this one. So let's do one more ledger transaction for another 100,000 muons. Or a lot of
we have
muons.
A question. One atom equals how many muons? So muons is just a denomination that is used in the testnet. In the mainnet, it will be atoms, or more precisely microatoms. But
yeah, and microatoms are 10 to the negative 6th atoms. Okay, again, we should see this delegation show up here as soon as that's included in a block. So here you can see both of the delegations. If you've delegated to multiple validators, this is what that will look like. All right. So that's the delegation transactions. If you'd like to withdraw rewards, there's also a transaction for that. Those transactions are going to look very, very similar to the ones I just ran, so I'm not going to go through that in the interest of time. As well as unbonding. So if you have delegated to a validator, you'd like to move those atoms over to another delegator, you would need to unbond them first. The unbonding period takes about 3 weeks, and this is to protect against long-range attacks and a wide variety of other things. We have a lot more information about that on the website, but just be aware that if you want to unbond from a delegator, there's a time cost associated with that. We do offer a nice affordance, which is redelegation, and that's just changing the direction of your delegation from one validator to the other, and it doesn't require unbonding. So there's a few options there. I would encourage you to look at the documentation. I do want to get to the part about governance. So as far as governance here, we now have query gov. So we've got this proposal here, and we've got a couple of folks who have now staked in the network and can vote on it. So let's vote on this governance proposal, and then I'll finish up with a couple of questions after I do that. Okay, so that's Gaia CLI TX Gov vote on proposal 1. I think all delegators should vote on all governance proposals. So you know what? I'm in favor of this, and I'm going to say yes. And I'm going to vote with my delegator key. Okay, and that's been included in there. And now when I query the proposal, nope. So this is the final tally result. It won't show up there, but query gov, I think it's tally. Yeah, you'll see my vote with all of my shares already there. And then if I want to vote with the ledger here, I'm going to say from ledger, approve the transaction over here. So the options here are view transaction and sign transaction. So you would ideally view it on the ledger first to ensure that everything's proper, and then you would sign it. and wait for it to be included in a block. And now we're going to see that tally increase. And as you can see here, when we query that proposal, you can see the voting start time and end time, and the vote will close at that point and then become final on the network. All right, that kind of concludes the core interactions that you as a delegator are going to have to perform on the network. I've talked through how to do that with the CLI. If you're looking for a UI way to do this, we do have a UI that's pretty substantially complete called Cosmos Voyager. The only thing that it's missing is a security audit. Otherwise, we would be showing you how to do all of this in Voyager today. So I would encourage you to go take a peek at that, but just be aware that it has not been audited and may result in loss of funds if you input your fundraiser key into it. So I'll stop right there and pause for questions.
So we have a question. Maybe you should go back on the tutorial itself. Can you restore an ICO seed into a ledger? So the answer is yes. There is a part on that in the tutorial. So the way it works is that you just go on your ledger. It's better if it's brand new, but if it's not, you can reset it. We don't advise it if you have already some funds that are secured by this ledger. But let's assume it's a brand new ledger device. So when you initialize the ledger, instead of going through the regular initialization process, you will go on. So I think it's a bit above on the Jack, if you can scroll up. Yeah, no, you're right. So you do not choose. No, you can scroll down. Sorry, I was mistaken. Yeah. So you do not choose the config as a new device option. You will instead choose restore configuration, right? And then you choose 12 words option because the fundraiser mnemonic had 12 words. And then you just have to input each of the words in the correct order. And after that, your ledger is set up and you can use it just like with a regular ledger.
And as Gautier notes here, this 1224 word mnemonic system with HD wallets built on top of it is standard throughout the cryptocurrency world. So you'll see these with MetaMask, you'll see these with Bitcoin, you'll see these with any network you're working with. So it's just the way that keys are derived off of the top of that changes. So that's what kind of allows this interoperability between all those different wallet software is excellent open source standards, which I'm a big fan of. Any other questions?
And just a quick note here, though, we only have like a few more minutes before we have to go. So
okay.
I think some of these you've addressed.
Okay. If there are any that I haven't, I'd love to get to those.
So we have some questions that are not related to the guide itself, so maybe we'll not answer
we move on there.
So there were just the recommended specs to run a validator on a VPS. It would be another topic. We don't have any recommendation for it. If you are running on a cheap VPS, you will not be able to run a proper validator. You can be sure of that.
Yeah, kb.certus1 is a great knowledge base for running validators. If you're looking to run a cloud validator, I have heard of some folks with some reasonably secure setups using the HSM integrations in various clouds. Before you tackle something like that, I would be sure that your DevOps skills are on point. So it is definitely non-trivial. Any other questions?
So do you not have a graphical user interface for Delegators? I think Jack addressed it.
I mentioned Voyager. As I mentioned, the only reason we're not doing this webinar with Voyager is because we did not have a security on it in time for launch. The product is excellent. I would highly advise folks check it out. The team there has put in a ton of work and produced something that's really great. You can delegate, you can vote, you can see network state, you can do all of that through the Voyager application. So I would encourage you to go take a peek over there.
Yeah, I'm not sure we already have released the web version of Voyager, which is the most up to date. So maybe the latest build is not actually synced with Gaia 11K. So be aware
that's a great point. That's a great point. Because that is still an alpha piece of software and has not undergone a security audit, we don't have strict version compatibility pinning yet for that. So that's another challenge in using Voyager right now.
Is Voyager
Michelle?
safe to use with Ledger? So
yes,
I think we've answered that.
Voyager supports Ledger. We just merged that integration about 2 weeks ago. I have personally reviewed it and it looks great.
It works, but it's not safe to use.
Yes.
Again, it's not undergone any security.
Sorry.
And I'm sure we'll have we already have folks working on third parties wallets. So I'm sure we'll have more options, if not before launch, soon after launch.
Lunamint, balance.
More questions about Voyager. Yeah, I think it's all the CLI related question.
Are there any Voyager questions on there that I can answer quickly?
I mean, there is one guy complaining about
Hey,
build of Voyager.
You know, I absolutely understand where you're coming from here, and we have been working extremely hard to launch this network. Essentially, a mismatch in security audit schedules meant that we were not able to launch with Voyager. However, if you go over on the GitHub and check it out, it's an excellent product, and it will be ready very soon post-launch, and likely before transfers are enabled. So before you're actually going to need to do anything besides run a couple of delegation commands, you're going to have a much better way to deal with these type of operations.
Yep.
And again, thank you very much for coming to the webinar and sitting through me doing a bunch of terminal stuff.
And again, this is recorded, and then we will post it on YouTube. We are going to try and start doing live streaming from this to YouTube, but this channel just allows us to be more question and answer than YouTube Live right now. So I think we got all the questions, right, guys?
I can't see a single one of them. So
I can't even test anything. But that's more of a statement. So I think we're good. And if you do have questions, like Jack said, reach out to us over our channels.
Yeah, Riot,
and
forum, email.
And if you're interested in Mainnet, keep up to date on the blog. There's Medium blog posts coming up that will give you an indication on what we have to do, so our pre-dependencies for launch. And then you can also probably, Jack, reference GitHub to kind of see how we're progressing through those pre-dependencies, right? People can check both Medium and GitHub to see what's going on in timing.
Yep.
Okay, cool. Thanks, everyone.
Excellent. Thank you, everyone.
Thanks, guys. Bye.
Bye.